Hello and welcome to CS264 Software Design. This is week 11 and this is lecture 22. This lecture is about working with software design patterns again, and we're going to be looking at behavioural patterns, the last of the three sets that we've been discussing over the course. In particular, we're going to learn a little bit about the behavioural software design patterns in general, but we'll work specifically with one called the Mediator pattern, and we'll see how to implement this in C# a little bit later in the lecture as well. First, again, as before, I've been using lots of examples from this book, Dive into Design Patterns by Alexander Shvets. You can either use the textbook or get the textbook, or use the website refactoring.guru and click through to the design patterns, in this case the behavioural design patterns, and if you want more detail on Mediator, there's lots there. I've only just produced a synopsis of some of the material that's there, and in other sources as well, but it's worthwhile using this book. Okay, so we're going to look at behavioural software design patterns then. Now, these ones are concerned with identifying common communication patterns between objects and then realising those patterns. A behavioural pattern abstracts an action you want to take from the object or class that takes the action. So by changing the object or class, you can change the algorithm used, the objects affected, or the behaviour, while still retaining the same basic interface for client classes. So behavioural object patterns use object composition rather than inheritance. These are not creational, it's about behaviour. So some of these patterns describe how groups of peer objects cooperate to perform a task that no single object could carry out by itself. And we're going to see that a little bit later when we look at the Mediator pattern. So an important issue here is how peer objects actually know about each other. So peers could maintain explicit references to each other, for example, but that would increase the coupling between them, and we don't want that kind of thing. So what happens then? Should every object know about every other object, or just some of the peers, or are there other ways to look at this? So how I'm working with how the objects behave is really why we have these kinds of patterns and why we need these kind of patterns. Okay, so when do we use them? So in order to address the potential for high coupling between peers, the Mediator pattern, for example, avoids all that by introducing a mediator object between peers. And the mediator then provides the indirection needed for loose coupling. Remember, we're all the time trying to look at loose coupling because we have to update an object or a class associated with that object. Then we don't want to have to update them everywhere, So it's really, really important that we have loose coupling or loose dependencies there. So, the chain of responsibility pattern is another behavioral design pattern that provides even looser coupling than Mediator. It lets you send requests to an object implicitly through a chain of candidate objects. And any candidate can fulfill the request depending on the runtime conditions. So the number of candidates is open-ended. You can select which candidates participate in the chain at runtime, so forth. So it's worthwhile looking at this one as well. But I guess behavioral patterns are concerned then with algorithms and communication between them. So the operations that make up a single algorithm might be split up between different classes, making a complex arrangement that's difficult to manage and maintain. So we want to try and avoid that. So the behavioral patterns capture ways of expressing the division of operations between all the classes and optimize how the communication should be handled. So there are three really simple ones, for example, and these are really useful patterns. They're strategy, state, and template methods. And you could look at those, and there's lots of examples online for all of these patterns, and becoming familiar with them a little bit, one at a time, will build up your expertise in software design. So, for example, what's key then really is to understand that behavioral design patterns are all about communication. So the focus shifts from the object and the classes that make up a design pattern to the actual communication between the objects and classes. And we've looked a lot earlier in this module about how to design and structure classes. This is about the behavioral now. So, we have a nice example here on the right that's according to the Gang of Four Patterns website. I have a link to this one here. I think if you click through, you should be able to go through to the link. Yeah, okay. And in its truest form of composition, behavioral patterns are best understood in terms of how objects work together to perform tasks. And it really is as clear as you can get in terms of, what's happening with behavioral patterns. So the emphasis is on interaction between the elements, and that makes they make up a pattern. So it's really important that some class diagrams look identical. So just the state and strategy patterns. So they look the same, but they behave differently. Okay, it's because of the way in which the participants communicate and how they handle responsibilities that makes them different. Okay, so you may see a number of patterns. You may see the UML diagrams for patterns, and find that, oh, hold on, that pattern just looks like this pattern, but actually it's how they behave. It's the algorithm in there that makes them work. Okay, so we have a whole series of objects, each with different responsibility, all working together in a communicating way in order to achieve some task. So when we talk about behavioral design patterns, we sometimes look at behavioral class design patterns and behavioral object design patterns. So they both describe anyway how a process or a flow. We saw previously that creational design patterns mostly describe some moment of time, that instantiation, and the structural patterns, they describe the static structures. So if we think then about behavioral, we have these two forms, class patterns and object patterns, and we've seen these before. So the class patterns use inheritance, subclasses, and polymorphism to adjust the steps that we're taking during the process. And the class patterns focus on changing the exact algorithm used or task performed depending on the circumstances. Whereas the object patterns describe how different objects work together to accomplish some task. So behavioral object patterns accomplish tasks that would be difficult or almost impossible to accomplish with a single objects. Sometimes you don't want huge single objects anyway. They generally make the entire flow simpler, more understandable, and more robust than solutions that are built without a clear design in mind. So what are these patterns then? So there's a list. You can check the list, the Gang of 4 list. You've seen some of these already, of course. Chain of responsibility is a pattern, and it's a way of passing a request between a chain of objects. Command, that encapsulated a command request as an object. Interpreter, that's a way to include language elements in a program. We saw a little bit about this previously. Iterator, that sequentially accesses elements in a collection, and we've seen a lot of collections in C#. And we looked at a lot of the libraries that dealt with collections, and really, you should have a look at Iterator and see how these actually work. Okay, they're patterns to make that work. Mediator, we're going to look at that in the rest of this lecture, and that defines a simplified communication between classes. Memento, you've seen before, it captures and restores an object's internal state. There's some more. Null object, that's designed to act as the default value of an object. Observer pattern, that's a way of notifying change to a number of classes. And we've seen these as well, we've seen and used these in event handling in C#. So, if you look up observer, you'll see how it works. State, that alters an object's behavior when the state changes. Again, that's like, this kind of thing is necessary when we look at event handling. Strategy, that encapsulates an algorithm inside some class. Template method defers the exact steps of an algorithm to some subclass. And visitor pattern, that defines a new operation to a class without change. So, worthwhile looking at all of these. I don't think I've links here, but if you go to the GeoF design patterns, if you go to the refactoring.guru website, you'll get the list and you can work through them and see them. Or you can get a textbook, of course, as well. Okay, so some rule of thumb then around behavioral design patterns. We've seen these before, and again, I've used this text to look at these rules of thumb because, sometimes I've taken out some of them that I think are interesting, but, you should check all of them. And, know where to find them. It isn't always necessary that you know everything off by heart all the time. You won't use all these patterns all the time, but the important thing is to know where to go, when you do need to find out about a pattern. So the behavioral patterns, they're concerned with the assignment of responsibilities between objects or encapsulating the behavior in an object and delegating requests to it. Chain of responsibility, command, mediator, observer, all address how you can decouple senders and receivers, but with different kinds of trade-offs. The chain of responsibility passes a sender request along a chain of potential receivers. Command, as you know, normally specifies a sender-receiver connection with a subclass. Mediator has senders and receivers reference each other indirectly. We'll see a little bit about that now later with a demo. Observer defines a very decoupled interface that allows for multiple receivers to be configured at runtime. Command and memento, as you know, act as magic tokens to be passed around and invoked at a later time. In command, the token represents a request, and in memento, it represents the internal state of an object at a particular time. So polymorphism is important to command, but not to memento, because its interface is so narrow that memento can only be passed as a value, and we know this. So you've seen this, you've implemented it in your assignments. maybe what you're not sure about is the command can use memento to maintain the state for an undo operation. Memento is often used in conjunction with iterator, and an iterator can use a memento to capture the state of an iteration. And the iterator stores the memento internally. Okay, that's nice to know. The visitor pattern is really like a powerful command pattern because the visitor may initiate whatever is appropriate for the kind of object it encounters. And the command that must be copied before being placed in history list acts as a prototype. And flyweight explains how and when state objects can be shared, and state objects are often singletons. So, we use a lot of the time there's this interaction between all the various patterns, and getting to know a pattern and how it relates to other patterns will make you really good at design. So let's look at Mediator then. Mediator, as I mentioned already, is a very simple straightforward pattern, has a structure that's similar to other patterns, but it simplifies communication between objects in a system by introducing a single object that manages messages or message distribution among all the other objects. So we have a mediator object here. It implements an interface, which is a mediator interface. So we have a concrete mediator. The components, in this case, colleague 1 and colleague 2, don't actually talk to each other. The participants, when they want to talk or change or access data, they make a request to the mediator. So this pattern is nice because it promotes loose coupling by keeping objects from referring to each other explicitly. So Mediator lets you vary their interactions independently. The mediator pattern helps to organize the code responsible for inter-object communication. So the communication objects do not need to know each other's identities. Mediator encapsulates a protocol that the communicating objects can follow, and the mediator object has a coordinating role. It handles the traffic between the relevant objects or parties based on its own logic or protocols. Let's fix this correction, this here. What should we do? Save it, because when I make it available for you, you'll be able to have a look at it. Okay, so there's a nice reference here from InfoWorld on how to use the mediator design pattern in C#, definitely worth reading. It's from 2017. Very, very useful and nice and accessible. And you can also check the gofpatterns.com. You can click the link and see the mediator pattern there as well. So there's lots of options for you to look at. Okay. So when do we use mediator? We're still looking at this. So we use it when a collection of objects communicate in well-defined but complex ways. The resulting interdependencies are unstructured and difficult to understand. So we've got some high coupling there perhaps. Okay. So we use mediator when reusing an object may be difficult as it refers to or communicates with many other objects. And we use mediator when a behavior that's distributed over several classes should be customizable without extensive subclassing. Okay, so these are good reasons to use mediator. I hope you can see that, of course. So we did look at facade at one point, and you said, is this not like facade? Is mediator not like facade? Well, yeah, it is, of course, but it differs from facade insofar as that mediator facilitates how a set of objects interact, while facade provides a unified interface to a set of interfaces in the application. There's a difference there. The mediator pattern, therefore, is behavior-based as it deals with object behavior, and facade pattern is structural as it deals with the object composition. Okay, so we have to get into our mind the differences between behavioral and structural. Okay. So let's have a look at describing this. Okay, so the participants here, we see if the UML diagram here, and I mean, you can either look at the gofpatterns.com, you can look at refactoring.guru, you can look at this InfoWorld article, but a lot of the time you'll see you have a mediator interface which is used to produce a concrete mediator class, and that mediator class then communicates with colleague classes or participating objects, and they of course implement this colleague interface as well, or subclasses from this. So this is an abstract class or interface. So the participants are the mediator, the concrete mediator, and one or more participant types called colleagues. The mediator is responsible for finding the interface for communication with the participants, and the concrete mediator, as it suggests, implements the mediator interface and has knowledge of the participants. Okay, so this is knowledge of the participants, and it's okay. In some implementations, you'll see alongside you'll have colleague and concrete colleague classes. Okay, as we have here. Okay, not everywhere. Okay, and the reason I chose mediator is because sometimes you see different diagrams representing as my example, you see different diagrams for the UML here, it's still Mediator. So for example, here's the one from the Mediator design pattern book in Dive into Design Patterns. So here we have the Mediator and we have components, and the components, the concrete Mediator knows about the components, and you can see that Mediator implements this. So concrete Mediator implements this Mediator interface, but this is slightly different from the concrete components here because they're, the concrete Mediator knows about them, of course, but they're implementing some other interface here or some other abstraction of some superclass here. And that isn't the case here. Okay, and here in this particular one, we see some details of what's happening inside the classes and how they work. So the design patterns book, you can read about the various descriptions here, but these are the same, in terms of good descriptions that you'd have in this particular example, but look slightly different. So here the participants are referred to as components rather than colleagues, and you'll notice that there isn't a component interface here as there was in the previous one, or component becoming a superclass. But don't worry, it's still Mediator. Okay. The Mediator design pattern promotes loose coupling by mediating the communications between the disparate objects regardless of how they relate to each other. Okay, and as long as the Mediator facilitates all of the interactions between the objects can be chained at will, and it is a Mediator design. It looks slightly different, but it is the Mediator design. Right. So, and there are lots of examples. I mean, what's really interesting, I think, and you probably are getting to see this as well now that you've been looking at generating the UML yourself from your own examples and your own exercises, that you'll see that that your realization might still be a command, or might still be Memento, or whatever approach you're using, or factory or abstract factory, looks slightly different from the UML that you'd have as part of the example, but it's still that particular design pattern that we're trying to get here. So for example, if you look at some of the Mediator demos online, and you can create your own, or you can run any of them that you see there. But here's one, for example, from .NET Tricks. So it's a real example about a Mediator, colleague, concrete colleagues. And now here you have some of the message, what's happening here in terms of the actual methods that are happening here, and then if you actually look at the Mediator example to build a design pattern, then you can actually see there are different names here, chat room here. Well, what's chat room? That's the Mediator. What are the participants? Well, what are the group A's? Group B. Well, you'll see if you work through the example, colleague A, colleague B, colleague, that's what's going on here. And then this knows about these and so forth. So it's still all the Mediator pattern, and you need to get used to looking at something and saying, oh yeah, that's Mediator, okay? And you can work from there when you see what's happening in terms of that design. And that's where you're ultimately going, okay? You can have a look at this article here, okay, from the .NET Tricks. I've given a link to it here about the Mediator design pattern in C#. And you can see an example of this. Don't think there's an implementation here, but there's probably a description that's worth looking at. Okay, so for example, there's another one on dofactory.com. Again, this is very similar, very similar structure, of course. Again, you'll see that it's almost identical. Okay, but they also give an example where they're looking at building a chat room application. So the Mediator here is a chat room which defines an interface for communicating with colleague objects. Then concrete Mediator, which is the chat room here, is the chat room interface. Then chat room implements a cooperative behavior by coordinating the colleague objects and knows and maintains its colleagues. Then each colleague, which is a participant, knows about the Mediator object, and each colleague communicates with the Mediator whenever it would have otherwise communicated with another colleague. So you can think about it like that. So when you're talking to somebody in what you think is a peer-to-peer type conversation, you're actually communicating via a Mediator. Okay, so lots of peer chat systems work this way. Okay. So some other excellent examples that use the C#. That use C#. There's a nice one here in the Mediator pattern in .NET Core. Part 1, what's a Mediator? Another one, the Mediator pattern in C#, and one Mediator design pattern in C#. You can click through to all of these, and you'll see some nice examples, real-world examples of how you realize the Mediator pattern in a real context. So, for example, I suppose what I really want you to get, of course, is that you have multiple objects communicating with each other. You can see that they each try to communicate with each other and becomes very complex, and there's lots of high degree of coupling, and we want to change it so that we have a mediating object here that does all of the communication. Okay, So this low representation is that loose coupling between objects 1 to object 4, and this arises because we've introduced this mediator object M. And that's it in summary, really, you know. So if you want to implement a mediator pattern, then you can work through all of this, okay, these examples here, and ultimately you want to look at something like this and build it. Okay, so you want to start with something like this, utilize this to build something that looks like this. Okay, that's the plan. Okay, so you can work through this list of examples, you know, in terms of that, you've got to declare a mediator interface, then describe the communication protocol between the mediators and the components. A single method for receiving notifications from components will do. That interface is crucial when you want to reuse the component classes in different contexts. So as long as the component works with its mediator via some generic interface, you can link the component with a different implementation of the mediator. It doesn't matter. Okay, so you have to implement a concrete mediator class then that would benefit from storing references to all of the components it manages. You saw that earlier. And you can go even further and make the mediator responsible for the creation and destruction of the objects if you want. It might be useful in terms of chat rooms and things, you know. At that point then the mediator can resemble a factory or a facade, so it's not really it's creational, you know. So it's not really mediating. The components then need to store a reference to the mediator object, and the connection is established at the components constructor, where the mediator object is passed as an argument. We can see that a bit later. And then we can change the components code so they call the mediator's notification method instead of the methods on other components, and then extract the code that involves calling all other components into the mediator class, execute the code whenever the mediator receives notifications from that component. So that's about sending and receiving messages between them. It's fine. Okay, let's have a quick look. I wrote some code. Okay, here's some code. Okay, so here's the system, my mediator. I'll give this code to you, of course. It's called my mediator. So you know we have a colleague here which you know knows about its mediator. Okay, and it has a method. You know, it needs to be implemented. Basically, it's a constructor here. Sorry. Then we have a concrete colleague A, and that basically just implements colleague. Okay, has a send. And it's going to send via the mediator messages, and it notifies, which sends messages to the display once it finds out and understands what message it has. So that's not too bad. Then colleague B, concrete colleague B, is just a copy of this. We have a mediator interface, which is about sending messages to a colleague that's registered. And then we have a concrete mediator, which implements this mediator interface, and then it just knows about colleague A, concrete colleague A, concrete colleague B, and they're both, you know, colleague 1 and colleague 2, their properties here. And then we can send a message then, so we can say if we get a message from one colleague, we can send it to the other colleague and forth. And this is the detail that, you know, this algorithm could be changed, okay, over and over again. But all that's happening here is if you get a message from one colleague, we send it to another and vice versa. That's all that's happening here. And our program then, that's okay, so it creates a mediator. Okay, then creates colleagues who all know about the mediator. We can see that we pass them this mediator here. And then we say the mediator colleague 1 is, so now we set up so that the mediator knows about all the colleagues as well. So the colleague knows about the mediator knows about the colleague. So essentially, if you've got a user in a chat room, the chat room knows who the users are, and each user knows which chat room they're in. So it's as simple as that. So then colleague 1 can send a message, or a participant from 1, and then colleague 2 can send a message. And we should be able to get the message notified, because the way we have it working here is that we get a message and we let it be known that we received the message. Okay, so here we go. Colleague A sending a message from participant C1. Colleague B is receiving a message that it received the message from participant 1. And that's because we did that here, okay? And then C2, I'm sending a message. Colleague B is sending a message, C2, so it's coming from this object class rather than the individual object name. And so we're sending a message, and then we have colleague A is receiving a message from participant C2. Okay, I've made a little mistake here in terms of my making them work. Let's fix this. I don't like when these things are not the same. Colon is here, so I didn't need to put a colon here as well. So I know it doesn't matter in terms of the operation of the program, but I do like it to run properly. Yep, okay, so that's fine. And it works as expected. Okay, let's go back to our presentation. Okay, so what are the pros and cons of Mediator then? In terms of the single responsibility principle, you can extract the communication between the various components into a single place, making it easier to comprehend and maintain. That's a good pro. The open-close principle, you can introduce mediators without having to change the actual components. That's really good too. And you can reduce the coupling between the various components of a program. That's good. You can reuse individual components more easily. You don't want the downside, of course, is that you don't want the mediator to become some kind of God object. And a God object, then, that's an object that knows too much or does too much. So it becomes bigger and bigger and bigger, and it becomes essentially an example of an anti-pattern. And an anti-pattern is a common response to a recurring problem that's usually ineffective and risks being highly counterproductive. And we want to avoid anti-patterns. Okay, it's really important for us. In relation, again, I mentioned in other design patterns, remember that facade and mediator have similar functions. They're both trying to organize collaboration between lots of highly coupled classes. Facade defines a simplified interface to a subsystem of objects. It doesn't introduce new functionality. So we want to look at like structural versus behavioral, okay? And facade, the underlying subsystem, in other words, the objects 01 or 01 to 024 we saw earlier, they're unaware of the facade, whereas objects within a subsystem working with facade can actually communicate directly. Okay, Mediator centralizes communication between the components, so objects 01 and 02 of the system, they only know about the mediator. They don't actually know about each other, so they can't communicate directly. So an interesting point in reading there as well, when I was looking at Shvets' book, the difference between mediator and observer is often elusive. And you can, in most cases, you can implement either of the patterns, but sometimes you can apply both simultaneously. I thought that was quite interesting. I mean, I can't go into it here, but I'd certainly recommend that you look at the reference to that. He has a nice description. It's, could be useful and certainly worth reading and thinking about. Check the book. I think I have the link directly here for you. Okay, so that's it. We learned about the behavioral software design patterns using an example. We were introduced to the mediator pattern, and we saw an example of its implementation using C#. Thank you very much for coming to the lecture.